this is going to be a relatively short, hopefully, short video on lesson 9 of the Sound and Light scheme of work, which is reflection. When you're doing this lesson, I mean, the first thing is you definitely should do what every science teacher does when teaching reflection, which is get the ray boxes out and get students actually drawing lines to see what they're representing with these ray diagrams and so on. So absolutely do the practical, and that will probably take a bit of time. What is in the lesson resources is more about identifying some of the key features of ray diagrams involving reflection, and it's also some practice at drawing ray diagrams of incident and reflected rays. And I thought I would just go through how I would model a few of these examples. Now these I've hand drawn in my book. I would recommend to you that you go on ExamPro or TestSpace or whatever and find some examples that have been drawn properly, because I've found in doing these that it's a little bit of a challenge to do it. Having said that, because it's not quite as clear cut in the ones I'm going to do, I think it's also not a bad thing to model to students. So anyway, the first example we've got here is a person looking at their shoes in a mirror, and there's a couple of ways of doing this. I think possibly the easiest way here, if we just assume that the person's eyes kind of form a vertical line down with the end of their shoe, one thing we could do here is just draw, and we can model this to students. We could say, well, we know that the angle of incidence is going to be equal to the angle of reflection, so this, we're going to draw these ray diagrams only after they've grasped the law of reflection. But I might draw something like this to say, well, okay, that is the line, the horizontal line between my eye and the mirror, and I'm going to assume that this is just on the ground at the same level. So what I can do is just measure this one, and that comes to 3.4. So if I divide that by 2, I get 1.7. So I'm just going to show students like this that that is where my normal is going to be, halfway between my eye line on the mirror and the floor. And then I can draw the normal in, and remember, this is what we really want them to be familiar with, is knowing what the normal is and how to then measure angle of incidence, angle of reflection, and so on. So then I'm going to draw from here, from the toe of that shoe, I'm going to draw a ray of light coming up here like this. I'm going to label that here. I'm going to then measure the angle, so you're going to need a protractor. This one's actually upside down, but hopefully you'll be able to model this to students and they'll see that. So I've got an angle here of about, it's not perfect, is it? So let's call it, yeah, it's about 8 degrees. So I'm going to label that on my diagram and show them that this is the angle of incidence. This is from what's being observed to the normal line. I'm going to say that's 8 degrees. And therefore, what I want to model to them is that the angle of reflection must also be 8 degrees. Now this is a test of how accurately I've done my measurements and so on. But if I go around to 8 here, so 1, 2, 3, 4, 5, 6, 7, 8, and hopefully you can see that, and students will be able to see that when you're modeling this. That's going to be about there. So then I'm going to draw, this is the moment of truth, I'm going to draw a line from my normal to that dot, and I might have just missed, yeah, I've missed, I'm going to the top of my head, so you might want to add an extra line in like that, something like that. Not the perfect one, but what you can do is show that that is the reflected ray, and then this, therefore, remember what we want to emphasize to students is we're always measuring between the normal and the ray, so this is going to be my angle of reflection, and that is going to be 8 degrees. So even with that example, you can see it's not the easiest to get right, and this is why maybe the printed examples are a bit easier. I'm going to have a go now live. Have practiced this with a few other examples, but this one is a new example, and when they're hand drawn, they're a bit of a challenge. But I'm going to show, okay, let's imagine now we've not got such a simple example. We've got, let's say, a parent and their child, the other side of a pond, and they're looking at one another in their reflection in the pond. Now what students need to grasp here is the normal is not going to be exactly halfway between the two, because they're different heights. So what we want to do here is just find the angle And to be honest, for the interest of time, I'm going to do this quite quickly, I think. But I'm going to guess what I'm looking for, and you can show this to students. You can measure with the protractor here, and they can do this again on the printed examples. This will be easier. But what you want to find is the point at which light is going to meet this reflective surface. So if I go to about here, then I can see that's going to give me an angle of reflection going to the eye of about 16 degrees. And this one, I could even get my ruler out. Well, what if I carry on past at 16 degrees? Well, that's going to go to the person's mouth. So if I move it a bit further that way, maybe that will do it. And again, you can talk through this to students and show them your thinking here. So let's try this one. It's to the eye. Again, that's about 16 degrees there. So if I do 16 degrees from here, yeah, I get a bit higher. So maybe I'll just move it a bit more, but approximately there. I'm going to put my dot. So then you can show them that the normal is now going to be displaced. And I'm going to do this a different way this time. I'm going to just, so let's say it's the child looking at their parent. So the light is coming from over here, like this, and it's reflecting into the child's eyes, so something like this. And it's just a good opportunity for you to show this, get them thinking in this example who's looking at who, and that's going to determine which way we're going to show the arrows. But if I'm doing the child looking at the parent, I'm going to do light coming like this and then into the child's eye like that. And again, here's the moment of truth. Let's see how accurate my diagram is. What you can do then is measure, and again, when you're measuring angles of incidence and reflection, show them that you're always going to put these lines are on the protractor up here on the normal, because you're always measuring between the normal and the ray. So I'm going to put that one up here, and I get an angle of, well, should be about 90 minus 16, 17. So yes, that's about 71, 2, 3. So I get an angle of incidence here of 73 degrees. And then I'm going to do it on here. Hopefully I get the same. Let's see. Oh, close enough. So this one's been a bit more successful than the last one. Yeah, that's about 74. And again, that's a good thing for students to talk about, is that the angles might not be, when you draw it, and they'll see this when they did the practical, they might not be perfect. And again, this is where you can get into an interesting discussion about, well, okay, is the diagram perfectly accurate? In real life, we would expect these two angles to be the same, so therefore there must be some error in measurement in my diagram. And the last one that I'll do is this one. So again, this is a bit of a tricky one, because now we've got an oblique surface. Sorry, I should have said this is a laptop. So this is actually taken from an exam question, quite an old one now, I think. And what we can do here is show students. Let's do that same method. So what you can do is say, well, look, I'm going to physically move myself around here because it makes it a lot easier. But I'm going to put my protractor on here, and I want to find roughly where the angle of incidence is going to be the same as the angle of reflection, and that's going to be where the ray actually hits the laptop. So if I go here, that's about 55-ish, and then if I go over here like that, and I do about 55, well, that's going to go about to the eye. So I'm going to have a go there, and again, just talking this through to students and showing them exactly what you're doing and talking through your thought process will be really, really helpful. So I think, approximately, that if light hits from the light bulb, if it hits the laptop here, then it's going to go roughly into the person's eyes. So I'm going to draw my normal line here. And again, it's really important that they're using that language and they're able to identify the normal. So I'm going to draw that here. I'm then going to construct, and again, I'm going to sort of slightly cheat here and work backwards. I'm going to go from the person's eye, sorry, to the person's eye like this. So I'm going to draw my ray coming here, and then I know this must come in at the same angle as it bounces off at. So I'm going to measure this line like this, remembering that this the bottom of the protractor always goes along the normal line. So So I'm going to go along like that. Now what do I get? This is where it's a bit awkward. So it's about 35.5 degrees. So again, ideally, if you do a printed one, you generally won't have to kind of do a 0.5 degrees, but anyway. Now if I then go like this, and I'm going to show them again, I'm putting the bottom of the protractor along the normal line. So I'm going like this, getting it all nice and lined up. 35.5 is about there. And then I can draw my diagram to show that. And this works pretty well. Here's the light from my light bulb coming in to the laptop like this. And then it comes off at the same angle and therefore reflects into the person's eye. So that's just 3 examples. A little bit it's a little bit of a budget construction on plain paper in my book, but if you go through a similar process and really draw students' attention to some of those core points about how you use your protractor to get these really nice accurate ray diagrams, that's going to be really helpful for them when they need to do it in real life and construct some of those diagrams for real. So I hope that's useful, and I hope you enjoy teaching this lesson on reflection. Next video we will look at some refraction.